This kata is a classic one. You need to implement a function that will convert a number to a Roman numeral. So besides learning super bowl numbers, you will also review a for-off loop to iterate over the array. I always confuse for-off and for-in, but this kata helps me to remember that if you iterating over the array, you need the for-off loop. Also, this kata reinforces destructing, and object destructing is pretty useful thing. And finally, you will be doing a while loop. Besides that, we're going to be using test-driven development, so you will get a chance to practice and learn test-driven development flow. So let's get started.
Let's take a look at the task. We need to create a function named toRoman that takes a single parameter. This parameter is num, it is integer, and we want to convert it to Roman numeral. So the function should return a string representing the Roman numeral equivalent to the integer. And then you need to convert integers in the range from 1 to 3,999 to their corresponding Roman numerals. So for example, if we do toRoman 1,999, we expect to get MCMXCIV, and if we do toRoman 58, we expect to get LVIII. We have a simple project named Roman Numerals Converter Kata. So it has two dependencies, assert, this will do the assertions, and mocha, that will run the tests. And we have a script test. And in the test, we're going to do mocha and run the test toRoman.test.js that is in the tests folder. Let's go ahead and look at toRoman.test.js in a tests folder. And right here, we are requiring assert, and then we also requiring toRoman function. And this function is in src folder. So let's take a look at it. And right here, you can see that it's just a stub. The function is empty, and we will need to fill out the logic in this function. So going back to the test, we have a describe function that describes toRoman, and it takes a callback function, and this function has it function, and we say it should return I for 1. And then we take another callback where we do the assertion, right? We do assert street equal toRoman, and then we have to have I. So if we convert 1 to Roman, we need to return I. Let's go ahead and run the test. So we'll do npm run test, and we're going to be doing the watch mode. So we'll do -- watch. And as you can see, our test failed. So let's go open toRoman function and make this test pass. In test-driven development, you make the test pass like the easiest way possible. So we can do return I. And let's go ahead and save it. And the test is passing. Now we got to green. So before we had red, now we got to green. So we're passing right here. And then the next step is refactoring. You don't have refactor after every test. You can refactor after a few tests, but in our case, let's go ahead and refactor. So we'll do if num equals to 1. We're going to return I. Let's go ahead and save it. As you can see, our test is still passes. Let's go back to the tests, and we can uncomment another test, right? And I'm just commented those tests to save some time. So now it says it should return IV for 4. So when we have a strict equal, when we pass toRoman 4, we're going to get IV. Let's go ahead and save, and the test is failing. So we got to red. Let's go ahead and get to green. So let's do another if statement. If num equals to 4, we're going to return IV. Let's save it, and we got to green. So we're not going to refactor here. Let's go to the next test. The next test says that it should return IX for 9, right? If we pass toRoman 9, we expect to get IX. So let's go ahead and save it. We are at red. So let's go get to green. If num equals to 9, we're going to return IX. All right, let's go ahead and save it. And we got to green. So now it's time to refactor. As I said, you can refactor in test-driven development after several tests. Obviously, with this if statement, we won't sustain very long, right, this conversion. So we need to come up with some kind better solution here, right? And to do that, let's first look at Roman numerals, right, how they look. So we have I, it will be 1. Then for 2, we'll have I. For 3, we'll have I. For 4, we're not going to have 4 i's, right, but rather I and V. So for 5, now we know 5 is V. For 6, we'll have VI. For 7, we'll have VII. For 8, we'll have VII. For 9, we're going to have VIII. No, we're not. So we're going to do I and X. This is 9, and then obviously X will be 10. So how are we going to convert our numerals, which are not really ours, they're Arabic, right, to this Roman numeral? So let's think about it. So let's say we have a number 3. So we're going to have an empty string, and we can push in the empty string the Roman numerals, right, or add it to the string. But since we're going to be adding it from right to left, right, we can see that certain numbers we can compose, right, like 2 and 3, but we cannot compose 4, right, because we're pushing from right to left. However, we can compose 6, for example, right, because we can push V and then we can push I into the string. So as you can see, there is like non-composable ones, right, like 1, 4, 5, and 9 and 10, right, and others are composable. So let's see, the lowest non-composable for 3 will be I, right? So we'll do 3 minus I, and then we can push in our string, we can push I. So the next, we now have 2, right? So 2 minus 1 again, so the lowest non-composable, and we're going to have I and push another I. So finally, we have 1 minus 1, and we're going to have I. Now let's go ahead and try a more complex example, right? So we'll have 17. So the highest non-composable at this point will be 10. So let's go 17 minus 10, and we're going to have X, right? So and now we're left with a 7. So now the lowest non-composable will be 5. So we'll do 7 minus 5, and we're going to have XV. So let's do next. We are left with a 2. Now we know the non-composable was 1, so 2 minus 1, we're going to have XVI. And finally, 1 minus 1 will give us XVII. So we see a certain pattern here, so let's go ahead and implement the solution using this pattern. Let's first, however, create this array of non-composable numbers, right? So we'll call it const numerals. And then we have an array, and we're going to have objects there, and we're going to start with a 10, right? We're going to say value 10, and then numeral will be X, right? So now the next one will be 9, right? So we'll put value 9, and the numeral will be IX. So the next non-composable will be 5, so we'll do value 5, and the numeral V. Fine. Now we need to put 4, so value 4, and the numeral will be IV. And then finally, we're going to get 1, right? Value 1, and the numeral will be I. So now we have the array of numerals. Let's go to the function. We can delete all of that. So now we need to set up the empty string. So we'll do let result equals to an empty string. Let's return this result. And now let's put the logic in. So obviously we have an array, so we're going to be doing for off loop, right? Let's start with that. For, we're going to go through each of these objects, but we can actually use the destructing and distract the value and numeral right away from this object. So let's do exactly that. So we'll do value, numeral, going over the array. So we're going to do for off numerals. And we're going to put, for now, let's just put an if statement, right? If num greater or equals to value. So let's go ahead and add the numeral to the result. So the result will be equals to result Since it's a string, we can just do add, and then we're going to do numeral, right? And then now we need to subtract the value from the num. So num equals to num minus value. I think it looks good so far. Let's go ahead and save it. And the test error still passing, so our refactoring worked. So we did red, green, and refactor. All right, let's go and uncomment the next test. And this says it should return LVII for Roman numeral 58. Let's go ahead and save it. And we're failing, right? You can see we have XI, XV, but we need L right here. So meaning that looks like our array doesn't have 50 and actually 40, right? Another non-composable in this pattern will be 40. So let's add those numbers to the array. So we're going to put 50 and the mapping will be L. And then 40, it will be XL. All right, let's go ahead and save it. And we can see that the test is still failing, right? We have VI, but we need to do VIII, right? And the reason for that is because we need to keep going, right? When we did a number 3, right? We need to keep subtracting and keep adding the Roman numeral to the array, right? The same way we did with the 17, right? 2 minus 1, 1 minus 1. However, we are not doing it. We just have if statement. So instead of if, we can do a while loop, right? So to keep going. So let's do while num greater or equals to value. All right, let's go ahead and put the result and num that we're calculating inside the while loop, and we can get rid of the if loop, right? Let's go ahead and do that. And our test is passing, right? So I don't think we need to refactor. Things looks good. Let's go to the next test. This one will be a little more complicated, right? We need to return MCMXCIV for the number 1994. Obviously, we're failing. We have a bunch of L's. We obviously need 1000 and 900 and 190, right? This is what our array is missing. Let's go ahead and add them. So we're going to copy, grab this, put them. We're going to start with 1000. And 1000 will be M. And 900 will be CM. So then 100, right, it's going to be C, because 900 is 1000 minus 100. So 100 will be C. And finally, 90 will be 100 minus 10. So it's going to be XC. All right, let's go ahead and save it. And the tests are passing now. This is good. Let's go ahead to the next test. And that's going to be even bigger. And this is one of our edge cases because we can need to convert numbers from 1 to 3999. And we need to get M, 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 C, M, X, C, I, X. If we're converting 3999, let's go ahead and save it. The tests are passing. That is great. Let's go ahead and uncomment another test. It's another edge case where it should return empty for 0 or negative numbers. And we are doing 2 assertions here, one for 0 and one for -1. Let's go ahead and save it. And this test is passing too, so I guess we wrote pretty good code. So, well, let's go to the next test now. It says it should return empty for numbers greater than 3999. So that's another edge case. Let's go ahead and save it. And we're failing here. So let's jump into the function and fix it. Fix will be pretty simple. We'll do an if statement. If num greater than 3999, right? We're going to return just the result, right? The result is empty string. We didn't get to for loop yet. So we're going to return result. And now the tests are passing. So you can see, right? We're passing all the tests. So we solved Kata. However, some of you may have noticed that we kind of skipped a few numbers in here, right? And you can see that we do not have 500 and 400, right? And that means your code in test-driven development is pretty much as good as your tests, right? You have to cover all the cases. So let's go ahead and write another test for, let's say, 437, right? So we'll do it should return, I'll just put empty quotes right here for number 437, right? And then we're going to put a function, and we're going to do assert strict equal to Roman, and we're going to do 437, and we're going to do again empty quotes. Let's figure out what it's going to be to 437. So 500 in Roman numerals will be D, all right? But we need 400, so 400 is 500 minus 100, and we know that 100 will be C. So this will be CD, 30, that's going to be XXX, and then we're going to have 7, which will be VII, right? So it needs to be CD, XXX, VII. All right, let's go ahead and save it. And the test is failing, so let's go ahead and fix that, right? So let's put 500 and 400 in our numerals array. As we said, 500 will be D, and then 400 will be CD. All right, let's save it, and all our tests are passing. So finally, I think we covered all the cases. So practice this kata every day for 7, maybe 10 days, or maybe a couple of weeks, so you can get hang of it, and basically you learn or maybe review the for off loop, the destructing, and the while loop. And after you master this kata, you can move on to the next one.